Eduhunt channel. Thank you.
Hi. Keep in view of your child's bright future. Please subscribe Eduhunt channel. Thank you.
Hello guys, for more exciting videos, please do subscribe Eduhunt channel. Thank you.
Hello friends, please subscribe Eduhunt channel and press the bell icon. Thank you.
Hello guys, please like, share and subscribe Eduhunt.
Hi friends, please like, share and subscribe Eduhunt channel. Thank you.
We have seen the equations of motion in case of a freely falling body and a vertical projection. Now let us see the actual applications of them. First one is we have to find the time of ascent. Time of ascent. Ascent means ascending, raising upwards. So if a body is thrown vertically upwards, the time at which it reaches the maximum height is known as time of ascent. It has several definitions. I will tell you one by one. The first definition is the time at which it reaches the maximum height is called as time of ascent. Second definition is the time at which its vertical velocity becomes zero is our time of ascent. The time at which its velocity becomes zero is known as time of ascent. So from our first equation of motion E equal to u plus at. So as to find the time of ascent, the velocity must be zero. The time at which the final velocity becomes zero is our time of ascent. That's why the final velocity will be zero. Is equal to u means how much? U only. But what is the sign when it is moving upwards? It is your choice. Let us take plus or minus. So let us take upward as negative, downward will be positive. Let it be. U is in the upward direction, initial velocity, so it is minus plus a into a means what? G. G is acting in the downward direction, that's why take it as positive into t. But instead of this t, I am going to write a special character, that is ta, where ta means time of ascent. So simplifying this, ta equal to how much? U by z. Means if you know the initial velocity with which you are throwing this object, you can find the time of ascent. Is it clear? Next one. Let us find the height, maximum height, to which the body can raise. Height. For that I am going to use my third equation, that is v square minus u square equal to 2as. When it reaches the maximum height, when do you say that it is at maximum height? The moment when its final velocity in the upward direction becomes zero is known as our maximum height, because its final velocity in the upward direction may become zero. That's why you can't go further. If it still has some velocity, it will move further. As it don't have any velocity in the upward direction, it stops there. That's why the maximum height is defined as the moment or the height or the position at which its velocity becomes zero is our maximum height. So the final velocity becomes 0 square minus u square. What about this u? Upward direction, negative. So negative whole square is equal to 2 into e instead of a I can write g into s means h max. What about this g? Is taken as positive. So let it be positive. So that's what is this? This is minus u square is equal to 2 into g into h max. See, what about this h? H is in the upward direction. So upward is taken as negative. So that's why I have to take negative here. This is negative. So this negative gets cancelled. And u square is equal to how much? 2g h max. See, what is the beauty of this equation? If you know the height up to which the body is raised, if you have already calculated height, you can find the velocity with which the object is thrown. Means you can find the initial velocity. See, if you know the height, your target height, you can find the velocity with which the object must be thrown to hit this. You can find this by using this. Got it? So if you know that the target is at 10 meters height, with what velocity I have to throw? Put 10 here and simplify, you will get u. With that velocity you have to throw the object. Or else, if you know the initial velocity with which you are throwing this object, you can find up to what maximum it can reach. How? By using this formula, h max is equal to u square by 2g. So these are our magical equations. By using these two equations, either you can find the initial velocity with which the object must be thrown, or you can find the height up to which the body can rise. So this is our maximum height. Now let us discuss about time of descent, and let us see the relation between time of ascent and time of descent. What is the time of descent? For example, a body is freely falling from certain height. It reaches the ground. The time in which it reaches the ground is known as our time of descent. So, for that, we have different methods to find the time of descent. Let us see. Method 1, S is equal to ut plus half at square I am going to use. If I know the height at which the object is falling, for example, a body is thrown vertically upwards, it reaches maximum height and it is falling. In this case, this time is called as time of ascent, this time is called as time of descent. If you know the height, or you can find the height, how? H equal to u square by 2g. For example, if the object is freely falling from this height h, then what? H is equal to u. Time of descent is used only in case of a freely falling body. Initial velocity is 0. See here, this is not the initial velocity. Here we have two cases. This is case 1, this is case 2. In case 1, this is initial velocity, this is final velocity. In case of freely falling body, this is our case 2, this is initial velocity and this is our final velocity. In case of case 2, what is this initial velocity? 0. So 0 into t plus half into a means g, which is in the downward direction. The body is moving in the downward direction, g is also in the downward direction, g into t square. Instead of t, I can write td, special character. As I already know the height, h equal to how much? U square by 2g. And I can write that u square by 2g is equal to half g into td square. This g can be taken in this direction, 2 gets cancelled. That's why it is u by g whole square is equal to td square. That implies td equal to how much? U by g. Earlier we have found that formula for time of ascent. We got u by g. Now again we got the formula for time of descent, that is also u by g. What does it mean? It means time of ascent and the time of both are equal. Means the time at which it reaches the height maximum height, the same time it can reach the bottom also. If an object takes 10 seconds to reach the maximum height, it takes 10 seconds to reach my position also. So this is the relation between time of ascent and time of descent. Yeah. Now let us discuss about time of flight. It has several definitions. Based on these definitions, we can find the formula for time of flight. Number 1 is the time of ascent and the time of descent is known as time of flight. In other words, the time in which the body remains in air is called as time of flight. The time in which the body remains in air is called as time of flight. See, this is the time 1, time of ascent. It is in air. It is coming from here to here. That time is time of descent. So this time plus this time, the body remains in air. So the time in which the body remains in air is called as time of flight, which is equal to Ta plus Td, which is equal to u by g plus u by z, which is equal to u by z. Means t equal to how much? T by z. Means this time of flight is directly proportional to the velocity of projection with which you are throwing this object. If you throw the object with more velocity, it remains in air for more time. That's all. Let us derive the same formula by using another definition, that is see, the object is thrown from here and reaches the same position. What is its vertical displacement? What is its vertical displacement? Its vertical displacement is 0. Now let us derive this formula by using another definition, that is the body is thrown from here, it reaches this point like this and it comes back again to the same point. What is its vertical displacement in this case? 0. So the time in which its vertical displacement becomes 0 is called as our time of flight. The time in which its vertical displacement becomes 0 is called as time of flight. So what is the relation between displacement and time? Our second equation, that is ut plus half at square. Yes, this becomes 0 is equal to u, initial velocity with which the object is thrown vertically upwards. Our negative minus u into t plus half into a g is downwards, taken as negative to t square. But this t is a special character, our time of flight. I'm going to define with mention with the capital T. So this is equal to, I'm sending this direction, ut is equal to half into t square. It gets cancelled. T equal to how much? U by z. So these are time of flight. Even like this also we can achieve this formula. Is it clear? So these are our time of flight. Next let us discuss the velocity with which the object reaches the point of projection.